Uh, I think in your book, you have stated that we stand on the shoulders of giants. I totally agree with that. And you
Hmm.
also give credit to a lot of school of thoughts when it comes to causal inference, right?
Yeah.
You talked about Pearls, Imbens, then Rubin. There are so
Yeah.
many schools of thought. Uh,
Hmm.
where do you personally align? I'm not trying to straitjacket you, but uh, do you have a specific preference of school of thought?
Yeah, that's a good. It's funny because if I read Pearl for a month, then I'm like, wow, Pearl, he understands everything. And then I read Ruben, I'm like, but I think Ruben, he understands everything. And then I read Pearl, I think Pearl, and then it's like that. It just goes back and forth like that. And that is, I think, part of my personality is like I do not like adhere strictly to schools of thought or even political preferences. I don't know. It's not natural for me to like really want to think something and not anything else. But what I can say is that I think I think in some sense I really like how Ruben's ideas tie very neatly into everything that we developed in the 20th century following Fisher about experimental design and randomization and um, that is a very appealing part for me of Ruben's ideas and how that, in a sense, Ruben's um, Ruben's model or Ruben's theory is less heavy in a sense. It's very abstract, which might be off-putting for some people, but I'm a mathematician, so when you can summarize a lot of ideas in a very elegant model, I think that is good. But on the other hand, Pearl is also very mathematically rigorous, but it's a lot more work, a lot more mathematics to get to the ideas. So I think they have both strong and weak points because Pearl, you have this more tools, so I think that's why it's very useful in industry. It's like you have more ways to answer your questions, whereas Ruben is like very it's so abstract in the sense that sometimes you're left wondering like, does this really work? So I'm not settled on which school of thought I like, but I also like and this is a little bit what I do in my book. I like the Hernan Robbins school where they kind of take the best of both worlds. They are epidemiologists and biostatisticians. And, you know, if you read their book, um, they talk about potential outcomes, they talk about DAGs, and Robbins formalized the unification of both that I haven't read yet because it's like a 200-page paper that's pretty dense, but I want to read it because the promise is that we can unify these frameworks theoretically, and that to me is very appealing. So I think as an applied statistician, what I advise in my book is just to use the tools that help you answer your questions. You do not need to worry about the foundational questions. And as a mathematician or as a curious person, I'm very interested in trying to unify these ideas theoretically so that we can stop worrying about who is right and just, okay, we have a theory that unifies these ideas because there are both different ways of thinking about the problem, but if they are true in a sense, there should be a unified way of talking about these ideas.
Understood.